Hi class, so if you're seeing this video, that means I am absent today. This video, guys, is going to be something a little different, something a little physics related. It's also very much real world related. Okay, so you're going to go ahead and watch a video on a couple of steps that I want you to follow. And from there, we'll be completing a Desmos activity. So today, your video will be to explore problem-solving skills and apply them to speed questions. So let's go ahead and get started. So we're going to go over a couple of steps. And these are just really good steps for any problem-solving that you have, whether it's in math or science or even in real-world situations. So you first want to identify the subjects, the who or the what. Okay, so it is, what are we solving? Okay, this is what we want to know. What are we solving? Then we're going to sketch and label, so that means to draw. The reason I want you all to draw is it really frames your mind about what's going on in the problem. Okay, then you're going to recall past knowledge, so you're going to think about previous learning. The reason for this is you might have already done a problem like this, or you might remember an equation or a solution, something very much related to what we're doing. Okay, you're then going to develop a plan of attack, and this means like identifying units and equations. Okay, you'll then set up your math and solve. So do the math. And then you want to do a logic check. A logic check means, does my answer make sense? Okay, so let's do a problem together, guys. So this first problem says, Chelsea left the movie theater and traveled toward the mountains. I'm assuming that's where she lives, but she's going to the mountains, so she's leaving the movies, going to the mountains. Trevon left 2 hours later, traveling at 45 miles per hour. MPH is miles per hour in an effort to catch up to Chelsea. After traveling for 3 hours, Trevon finally caught up. What was Chelsea's average speed? So there's a lot of information, okay? So let's first identify the subject. So our subjects is Chelsea and Trevon. So I'm going to write Chelsea here, and let's write out Trevon here. Okay, so we've got that. Now let's sketch and label each subject. So what is happening with Chelsea? So Chelsea's at the movies. I'm going to put an M here for movies. And she's going to the mountains. Okay, here's our mountain. So she's going over here. Okay, that's everything from the first sentence. So then let's talk about Trevon. So Trevon, he's also at the movies. And he's going to take off and try to follow Chelsea to the mountains. Okay? But he left 2 hours later. So let's write that down. Left 2 hours later. But he's also traveling at 45 miles per hour. And y'all see MPH. And that's awesome that you guys know what miles per hour are. But when we talk about units, guys, I want to make sure that we understand what that really means. So she's traveling at 45 miles, okay, for every hour. So that's going to be for every 1 hour. So 1 hour, she's traveling 45 miles. Cool. This is going to be important when we do some of the math right now. Okay. Then it says for after traveling for 3 hours, so he's doing 45 miles at 1 hour for 3 hours. Okay, he finally caught up to Chelsea. And so we want to know Chelsea's speed. Okay, what is Chelsea's speed? So we have all this information on Trevon, but we want to solve for Chelsea's speed. So when I'm looking at this, okay, we've already got this sketched out. Let's recall past knowledge. Well, past knowledge is we're doing speed problems. Speed is distance. So let's write that out. Let's say speed is distance over time. Okay? So we have that. We have this 45 miles per hour. So this is important here. Okay? So we've recalled, and let's figure out a plan of attack. So we want to know when they catch up. My thing is like, we got to figure out some other stuff, like how far are these people going, right? So we can figure this out. We know that Trevon is going 45 miles per hour, and he does this for 3 hours. So let's figure some stuff out. Let's find out our distance. And so when we set up this speed equals distance over time, we can say, that our speed is 45 miles per hour equals, well, we're looking for distance, but we know how much time, 3 hours. So let's solve for the distance. Our distance would be 45 miles per hour times 3 hours. And so when we multiply this out, 45 times 3 is going to be 135. These hour units would simplify out miles. So Trevon and Chelsea are traveling a total of 135 miles. And I'm going to go ahead and underline this. This is important to me. So we know that Chelsea's traveling 135 miles. So we want to know her speed. So her speed is equal to her distance over time. Well, her distance, we know that she's doing 135 miles. Over her time, well, how long was Chelsea traveling? Well, Chelsea left, right? 2 hours later, 2 hours later, Trevon leaves. So 2 hours pass, and then 3 hours after he left, Trevon catches up to Chelsea. So that's a total of 2 plus 3 is 5 hours. So when we simplify this, 135 divided by 5 is 27 miles per hour. And this would be our answer. This is how many miles per hour Chelsea is traveling. So we did our plan of attack, we set it up, and we solved. Now let's do a logic check. So let's discuss this. Chelsea leaves. Okay, she gets a 2-hour head start on Trevon. So Trevon moves as fast as he can for 3 hours at 45 miles per hour, and he finally catches up to her after a span of 5 hours of Chelsea traveling. So this means that Chelsea should be going slower than Trevon, because Trevon traveled for less time, 2 hours less time. So is 27 less than 45? Yes, it is. So this logic check makes sense. Wow, that was a lot, right? Okay, well, these are how we dissect problems. And it's not so much the math, guys. It's the thought process that I want you guys to focus on. It's how do we figure this out? Because the math itself, we did a little bit of multiplication, a little bit of changing things up. The math wasn't difficult. It's how do we solve this? Okay, so let's do one more together. So let's read the problem and let's identify the subject. So it says, Callie left the mall and drove south. Okay. 1 hour later, Gabriella left driving at 75 miles per hour in an effort to catch up to Callie. After driving for 4 hours, Gabriella finally caught up. What was Callie's average speed? So these girls are going fast. So let's identify our subjects. Subject 1, we have Callie. Okay, Callie's here. Subject 2, we've got Gabriella. Okay, and we've got her here. So we've identified. Let's sketch and label what's happening. Okay, so let me pick a different color. So we'll say Callie's at the mall. And she's going south. Typically south, if you look at any map with Cartesian points, south is down. Okay. Then we've got, Gabriella. Gabriella also leaves the mall and she's going south. trying to catch up, okay, to Callie. But there's some extra facts here. They tell us that Gabriella is going, okay, well, she leaves 1 hour later. And that she's traveling at 75 miles per hour. Okay? And she does this for 4 hours. So that's all the information they gave us. And they want us to figure out, okay, what is Callie's speed? This is just like the last problem. So let's go ahead and crunch through some of these techniques, right? So we know speed is equal to distance over time. So for Gabriella, we know our speed. My speed is this. And we know our time. Our time is 4 hours. So we're going to look for the distance. Okay? So let's do this math here. We're going to say 75 miles per hour is equal to distance over 4 hours. So we're going to want to solve for distance. So to isolate distance, we want to multiply both sides by 4. All right, 4 hours. So let's clean this up a little bit. We're going to say distance equals 75 miles per hour times 4 hours. And I know this math works because if you look at our hour units, these will simplify out, leaving us just with miles. So distance equals 75 times 4 is 300 miles. And I'm going to circle this. This is important. So we know that Gabriella and Callie both travel a total of 300 miles. We know Gabriella's speed is 75 miles per hour. She does this for 4 hours. Okay, now we got to figure out Callie's speed. Well, Callie is different because when we do speed equals distance over time, we're looking for speed. Okay, so speed equals, we know that she travels a total of 300 miles, but her time is different because it took Gabriella 4 hours of travel plus the 1 hour of wait time, so this was a total of 5 hours. Well, when we simplify this down, 300 divided by 5 is 60 miles per hour. So let's rewrite this. We're going to say Callie's speed equals 60 miles per 1 hour. Okay, wow, we did a lot and we did that really fast. Well, let's do a logic check. Gabriella traveled for only 4 hours at 75 miles per hour. Callie got a head start. So if Gabriella is able to catch up to Callie, that means Callie has to be going slower. Is 75 miles per hour slower than 60 miles per hour? I'm going to say yes, it is. Okay? So great. We have our problem solving skills here. I want you to take these skills, guys, and you're going to apply them to today's Desmos activity on speed, distance, and time. Guys, make sure that when you log into Desmos, you put in your full name, because when I check your classes, I want to see 100% completion for all of you all to get credit for this activity. Best of luck, and we'll see you the following day. Bye, guys.